Hey, hello, this is Bob Jackson. We're back at SC201. And this is chapter 9. It's chemical reactions. I love teaching about chemical reactions. Chemical reactions is an important part of chemistry. We started chemistry with chapter 8. Chapter 8 was chemical changes. Okay, and the way the original itinerary was set up was to teach both of these together in 1 week, and I felt like it was way too much content for 1 week, so that's where I broke them apart. I would never, if I was teaching a class like I taught high school chemistry for years, ever would have loaded that stuff up all together, or even have it on one test at the high school level. Okay, so now then, this is chapter 9, like I say, and it's on chemical reactions. I think this content will be appropriate for the upper elementary levels for sure. And I know that because I have done some chemistry workshops with fourth, fifth grade teachers. And I'm not teaching anything in this above what I've ever done with workshops with them. In the Indiana state standards, this all fits under the physical science standards. Okay, they don't really call it chemistry at the elementary level, but it is physical science, no doubt. And it's a very basic chemistry, and it is physical science as well. Okay, I'm going to keep you out of the tough stuff. We're not going to go into the mathematics of it to any extent besides balancing equations. I do really feel that the earlier we introduce this to students, the better it is, because chemistry is a subject that's become more of a requirement for students entering college. And it's also a basis for so many different areas going into ranging from medicine, pre-med, nursing, the engineering areas, each of the different engineering areas, pharmacy, pharmaceuticals, to even the people headed off places like Purdue to where they're picking up the ag degrees. There's so much chemistry in farming today with the herbicides, pesticides, and fertilizers, to all kinds of products. I mean, the material science in the world today for all the different materials we're using, and ranging from computers to cars, it's all chemistry. So chemistry has become so important. Even our computers and the chips and so forth, in robotics, all has a chemistry basis to it. So the earlier we can introduce some of the base concepts, the better off we are. Okay, so let's get started. Okay, so let's take a look at the slides. Okay, we'll go back here. Okay, on the first slide, it's I'm showing you, and I'm telling you that we're going to talk about chemical properties, chemical changes. We're going to do some very basic balancing equations work, and then I'm going to take you through types of reactions. So when you take a look at a reaction, you can tell what type of reaction that it is. And that's pretty simple chemistry. And believe it or not, kids can pick up on that pretty quick and easy. Okay, if it's taught to them right. Okay, let's go in here. Okay, so here we have chemical properties. Okay, and if you take a look here on this slide right here, then you see this vehicle sitting here. It's been sitting outside probably for decades. It's rusting. Well, it's got a chemical property that makes that happen. Okay, it's rusting, it's oxidizing. Those are all chemical properties. Okay, of that substance, it is a metal, and it's made of metals that are going through that. The metals have those properties, and it deteriorates through time. Okay, so we start recognizing, the important thing is we start recognizing what chemical properties are. Chemical properties lead to substances changing, becoming something else. Whereas when we talk physical properties and physical changes, like water freezing, water evaporating, water, or like dry ice subliming, okay? No matter what, when those changes took place, it stayed what they were. Okay, if water freezes, it becomes ice, but it's still water. If water evaporates into the air, you still got humidity in the air, it's still water. The water goes on up in the sky and forms clouds, it's still water. Okay, whereas when we talk chemical properties and then chemical changes, the substances become something totally different. Okay, so like something burning, that's a chemical property. If it will burn, it's a chemical property. Wood burns, paper burns, fuel burns, gasoline burns, diesel burns. Those are chemical properties of those substances. Okay, not all things will burn well, thankfully. Okay, but it's a chemical property. Here we're cooking a steak over, it could be a gas grill, which got a fuel that has a property of being ignited. Okay, or it could be charcoal, okay, that has the chemical property. Fireworks, we can only make fireworks out of certain materials, substances that have rather explosive nature, but when they explode, they create some nice colors in the sky. Those are chemical properties unique to them. Some of the metals are like sodium and barium and lithium, small amounts of them in those explosives that give the colorations that we see in the sky. Okay, and it's actually pretty cool. But you get to know chemistry and making fireworks. This statue you see has turned green and kind of ugly looking through time. Those chemical properties causing that. Okay, on this faucet here, you see lime around it right here. That lime come out of the water, chemical reaction took place here. That's chemical property. Okay, so a chemical property, this metal, when it comes into contact with what we call hard water, this can happen. Okay, which they have started changing the metals that they use in these, but we've also got water softeners and water filters and so forth that we use to change the properties of water so they don't do this, but it's all chemical properties. Here we've got either natural gas or propane burning. That's a chemical property, and that's what you'd want to start showing students is those properties. Okay, as chemical properties. Okay, the next page. Here we're going to just dive into chemical properties more and actually name some that I think no doubt kids at younger ages can begin to recognize and know and should know. We should be teaching these. These are things to be aware of in life and become safer and more cautious and just aware of things. Okay, so some chemical properties of some common items that are around households and garages and that people use all kinds of places is burning. We have combustible materials. We have substances that undergo oxidation, or what we call it, we say it oxidizes. We have materials that are corrosive or undergo corrosion. It's the same thing, just according to how we're talking it. Toxicity, that's where substances we know, chemicals, whether it's herbicides, pesticides, fertilizers, cleaning agents, solvents, have toxicities, okay, which are poison to us or poison to animals. That is a chemical property, or those are chemical properties, okay. Acids, we say they're acidic, okay, so if it has an acidic property, it is an acid, and it causes certain things to happen. Okay, and then you have what's opposite acids or bases. You say they're basic or you say they're alkaline. Something that's alkaline is basic. Okay, bases are kind of opposite of acids, but bases can be extremely corrosive to objects and things. Okay, so each one of these are chemical properties. Now, I think most of them are self-explanatory, like burning. It's flammable, okay? It goes right with flammability. It will burn. It will burn in the presence of oxygen, typically. Now, something combustible, it's different than burning. A lot of people confuse these two. If it's combustible, it's a fuel that is made of carbon that's reacting with oxygen. Okay, combustible materials all have carbon in it. Okay, and a lot of them we use in furnaces, we use them in engines, we use them in different things where we're combusting, and typically they're inside a cylinder of a car. They're inside the inside your furnace in a contained they're contained in a combustion chamber. Okay, combustibles. Okay, now you can have them combust outside of that, and that's where we get into our fire hazards and so forth. Just like gasoline sitting in a garage in a container is combustible and it can become dangerous. Okay, oxidizing is where this is very common with metals. And when metals rust, they oxidize. That's what causes rusting. Oxidizing is it's breaking down. Okay, it's like iron becoming rust, aluminum becoming aluminum oxide. Doesn't look the same anymore, and the metal is deteriorating. Okay, oxidizing is really where that substance is giving up electrons and becoming ions. Okay, that's why it's breaking down. It's going from the elemental form to ionic form slowly, but typically slowly. Corrosiveness is very similar in that it is most time it is like an oxidizing process. It typically just kind of looks different and can be it can take place without involvement of oxygen. Most of the oxidation you see out there in the natural world has oxygen involved to cause it to happen. Corrosivity is like if you leave batteries sitting inside a flashlight for years and you open the battery up and you see all that corrosive battery in there, maybe it's even hard to pull out of there because that corrosion occurred. Okay, and that's where very much a lot of times corrosion occurs with and around batteries. I've seen it more than anywhere. And that's where get the term alkaline. You have alkaline batteries like double A's, triple A's, C's, D's, 9-volt batteries. They're all alkaline batteries. They have bases in them and they cause corrosion through time. Okay. Your car batteries are acidic. They have acids in, not bases. And the acids can be very dangerous. So the acids very commonly react with a lot of metals to produce hydrogen gas, which is explosive. It's all talking chemical properties. Okay. And then toxicity, I've already, I think, talked through enough. It means it's a poisonous material. Is it poisonous to you, me, dog or cat, or to other animals? Toxicity. Now, at the elementary level, what I think is most important is start getting the kids to observe things around them. And that's where you get in industrial sites and even storage spaces in schools, or even maybe at home and in garages if their dads and moms have taken care of doing things. But they could see signs like these that tell them something about chemical properties of stuff stored there, or even driving down the road on the back of a semi, on the back of a tanker truck, on a train that's going across the railway. These signs are telling us about the materials that they're carrying or that is stored at the site. So you want to get kids to recognize these and realize there's stuff here that has chemical properties that can hurt me ultimately, but also cause reactions that I really don't want taking place maybe. Okay, so from toxic hazards to here you see this, the red here is concerning diesel fuel is pretty high flammability. Okay, but not nearly as high as gasoline. And that's where the higher the number, that the worse it is. Actually, diesel is a lot safer to work with than gasoline in enclosed areas. There's toxic material stored here. Okay, corrosive. You see this sign up, it means there's substances here stored that cause corrosion to metals, particularly more than anything else, and can cause to tools, to other different materials that you see. And also most corrosives are particularly very good for us. Okay, getting on our skin and so forth. Okay, danger acid. So it means there's acids there, combustible materials, flammable. These are just different signs you can see and get kids kind of to recognize and let them know. The biggest thing, kind of let them know to chemistry titan. These are giving us information about the chemical properties of the substances around us. Okay. Okay, here we're going to go to chemical changes, where we just kind of talk some rather than just putting it all the properties, but it changes. We got chemical change taking place there when that's on fire. We say it's flammable, it's burning. Okay, it's flammable, it's burning. Okay, the candle. Okay, those are chemical changes. That wood's becoming something else. That candle's becoming something else. We don't have to worry about this stage of what something else is, but it's going a chemical change. Okay, combusting inside of an engine when we're burning fuel and the engine's running, that's combusting. Remember, combusting always involves a carbon compound and reacting with oxygen. Okay, so that's what's taking place here. Here we got beer vats. I don't know whether you want to teach this in elementary, but those are beer vats, and where they're brewing some beer big time. But you got fermentation taking place there. That's chemical change. Fermenting, that's how it's called. Okay, nails rusting. Here we've got sterling silver tarnishing. It's turning colors on you as it sits through the years. Okay, those are all chemical changes taking place, and you get students to recognize these. Okay, and there's actually all kinds of stuff around. You look on the sinks at home, you look on shower heads, you look at different things around, to rust forming on cars, rust forming on fences, rust forming on any metal that's sitting outside, on buildings or anything else. Okay, and we'll go to chemical equations. Okay, we want to start getting kids interested in chemistry, and we want to get kids to recognize chemical equations and not to be scared of. Chemical equations are for lazy people. So we don't have to write out these big word equations for every reaction we ever work with. We'll write it in a shorthand form. Chemical equations represent chemical reactions. Okay, all that's in them are chemical formulas of compounds and symbols of elements. Okay, now it takes some time to get those learned as far as the names of the elements and names of compounds. And we're not going to try to teach that to the kids right now. Just get them to recognize them. Okay, like with the last chapter, you named a few compounds, very simple ones. We're not going to concentrate on that for 4th or 5th grade. We're going to concentrate, get them to see what a chemical equation is. Okay, so here's one right here on the screen. This has hydrogen reacting with oxygen to give you water. Okay, so the big thing to know now, these over here are called reactants. These are called products. Here I've got an equation form. If I could actually see it, it'd look like this. Here's my oxygen molecules. Well, I'm sorry, here's my hydrogen molecules. Here's my oxygen molecule. Okay, that says 2 hydrogens. There's 2 hydrogens. It's H2. So there's 2 of them there. There's 2 of them there. H2, H2. There's 2 of them. O2, right there. 2H2O here. Here's O, H, 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 O. 2 H2O. Okay, so this chemical equation is representing this reaction. It's also written down here. Okay, and this is just putting it a little bit clearer and on a slide by itself. These over here I'll call the reactants. These are called products. Okay, the numbers down here are subscripts. Okay, if you have numbers down on the elements, they're subscripts. Okay, if there's no numbers down there, it means a 1. We don't write 1s in for anything. So there's 1 copper, 1 nitrogen, 3 oxygens. But if I have parentheses, I'm going to multiply these. So there's 2 times 3, 6 oxygens there. Okay, since this 2's out front, and I got a 3 on this, there'd be 6 oxygens there. Okay, so now then, these are subscripts. These numbers out front are called coefficients. When we go to balancing equations, the only numbers we ever change or put in are coefficients. Okay? We never change subscripts. They stay the same. We can't change subscripts. We would change what the substances are, and that doesn't happen. Okay, and what we're doing. Okay? All we ever change are the coefficients. Let's go to done. Okay, here we have a chemical equation. It is not balanced, and we are going to balance it. Okay, And the way you see it's not balanced is there's 2 hydrogens there. There's 2 there. Well, those are balanced, but there's 2 oxygens here, but and only 1 over here. Okay, because that 2 goes to that hydrogen. So I have to balance them. So now then you can start putting your numbers in anywhere you want. You're always going to, all the ones you're going to get for me showing you guys from doing elementary school are going to be small numbers. Okay. You're not going to have any numbers, very rarely will you have a number bigger than 5. Okay. Most of the time you're going to use 2s and 3s and 4s. Very rarely will you go higher than 5 once in a great while. Okay. And you don't put 1s in because they're already there. Because what's in front of all these right now is 1 hydrogen or 1 H2, 1 O2, 1 water. Okay, so they're not written in there. So now to start balancing this, we have 2 H's. We have 2 H's. Those are balanced. I have 2 oxygens, but only 1. So I'm going to take and put me a 2 right here, because the only place I can put numbers out front. I can't change the numbers and I can't put them in between them. Put it out front. So it's going to be 2 here, 2. So now I've got that balanced. And now what's not balanced now is 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. So I have to go over here and put a 2 over here. And it's done. That's balanced. I completely did that when I balanced that equation. It's like working a Sudoku. Okay, and you can start anywhere you want to on. Okay, we'll go to this next one. Now then, anytime you see these are called polyatomic ions. The most common ones all have oxygen in them. So you have like NO3, SO4, SO3, PO4, PO3. You look at those as one unit because you'll see NO3 here. You see it's NO3 over here. It never changed. So like you have an SO4 here, you'd see an SO4 over here. So you look at those as one unit and makes this a whole lot easier. Okay, so on this one, when I go to look at this, got 1 copper, 1 copper, 1 silver, 1 silver. Okay, 1 nitrate, that's what that thing's called. You didn't learn them after you just run chemistry for a while. This is a nitrate, but there's 2 of them. So I'm gonna go over here and put a 2 right here. Okay, so when I put that 2 right there, then I have to come over here and put a 2 right there, and it's balanced. Okay. Most of them work that easy. I mean, it's not that hard. Okay, let's go to the next one. Okay, so now here we have sodium reacting with water gives sodium hydroxide and hydrogen gas. This is a cool reaction, but it is dangerous. You produce hydrogen gas, which is extremely explosive. Okay, so now see if you can balance it. And then I'll help you. Take a few minutes and see if you can balance that. You start seeing where the numbers are different, throw your numbers in. The easiest numbers I always start with is number 2. And then if number 2 doesn't work, you go up to number 3 and so forth. Okay? Are you getting it? Okay, here it is. And now then when I did this one, all right, I seen an OH here, which gave me 2 H's and 1 here. And I had 2 over here. So what I would start this, I would put a 2 right here. Because 2 hydrogens here and 2 here. I can put a 2 here to give me 4. Okay, because like here when it started out, I can't go backwards yet. Okay, if I have this here, okay, and this here, that's 3. This is 2. Anytime I have an odd number, that's a problem. First thing you want to do is make an even number. The only way you can do that, you can only put a number out here. I go 2 here, and then that'll be 2 hydrogens here and 2 here, that's 4. Well, what times 2 is 4? 2. So that's why 2 there, 2 there. But then if I put that 2 there, then I have to jump over and put that 2 there. Okay? And it's balanced. See what I can do the next one. Okay, now if I was in this one, what I do, since I see a 2 here, and it doesn't matter where you start, I just gotta give hints. Since I have a 2 there, there's 2 chlorines and only 1 there, I'm gonna throw a 2 right here. Okay, just because I see that's different than there. And any of them that have hydrogen, I typically hold hydrogen till last if I can. Because I can just make it, it'll usually just fall into place. Okay, so 2 chlorines, I put a 2 there. And it gives me 2 hydrogens. Well, there's already 2 there, so it should be balanced just by doing that. And it is. Okay. That's balancing equations. You're not going to have any to speak of tougher than that. Okay. Now, this types of reactions, like where students start recognizing basic types of reactions. Okay. Here is on this screen, what you're seeing is a way of looking at them. Okay, you want to look at all elements as just being A, B, C's, D's. And they can make this whole thing of recognizing reactions so much easier. So if I take a reaction where I have element A and B and I just simply put them together, A, B, put them together and form AB over on the other side, it is a synthesis reaction every time. You can also call it a combination reaction. So we got A, we got B, we put them together, A, B. Okay. Now, if I do just the opposite of that, if I take 2 elements that are put together and through the reaction I blow them apart, which can literally happen, then that's a decomposition reaction, which is just opposite of the synthesis reaction. Okay, so I could have like H2 and O, and I blow them apart into hydrogen and oxygen, which is a reaction that takes place. Okay, electrolysis of water. Okay, now then down on this one, we have single replacement and double replacement. This book likes to call. You can also call them single displacement, double displacement, and that's where I've always called them SD and DD or double D. Okay, so there's displacement taking place in both of them. Okay, so the way you look at it, you get your A, B, C's. That's your elements. You look at these as elements. Okay, you take element A, element B, element C. Okay, and if it is set up like this, a single replacement reaction or single displacement, element C tries to knock one of these folks out of here to get with this person. So this is like a couple dancing. This dude wants in on the action. So he comes over, knocks her out, and gets with him. Okay. That's a single replacement reaction. Now it takes a big enough, bad enough dude to do it, but we're not going to worry about it at this stage. Just get you to recognize types of reactions. Okay. And not all of these reactions will take place. So, because like if I have sodium here and I have potassium here, that reaction is not going to take place, but it's that's what you'll learn through time. But I'm not going to give you any reactions that don't take place. Okay. So anyway, you'll see this push B out. B ended up out by itself, and C ended up with A. Now they're dancing, and that dude's by himself. Okay. Double displacements very similar, except you have element A and B together here, element C and D here. They're going to switch partners. And here you got these two, you got these two, and they're going to switch partners. Okay, so you see that C goes over here, B goes over here. Okay, these two are these A and C are together, B and D are together. Okay. No, actually, that's wrong. But it's all right for what we're doing. There's another part of it that should have been A with D and C with B. Whoever put that together, but it's all right because you're gonna see it this way and it'll be fine. Okay, and you'll see when I get Johnson problems because they can only switch around. Okay. Now then, combustion reactions. Combustion reactions always have a carbon compound in them. Always, 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 always. It doesn't matter how big it is. This CH4, that's methane, that's natural gas. But it can be like C20 something. Okay. They're always fuels. They're always carbon compounds that will burn. Okay. Always, always, always carbon compound. But then the rest of this is the same in every combustion reaction. It doesn't matter what it is. The only thing that changes is this. One of the reactants is always oxygen, and both products are always just CO2 and water. Okay, and that's how you recognize combustion reactions. CO2 and water over here and oxygen right there, it's a combustion reaction. I don't have to go any further. But this does have to be a carbon compound. Okay, let's do this. Okay, identifying types of reactions. Here I have A, I have B. I put them in together into one thing. A plus B, put them together into one thing. Synthesis reaction. Okay, this is a compound A and B together. Now I pull them apart. Now I'm not worried about the numbers that are on them. I'm just looking at what the elements are. H and O. Okay, don't worry about what the numbers are. Okay, so A and B together, I pulled them apart. Decomposition reaction. Okay. 3, I have A and B together. I have C and D together. They switch partners dancing. This is a dancing couple. This is a dancing couple. Okay. This goes over here. This goes over here. So I end up with a FES and CaCl2. Or just all you got to look at is CaCl. Don't worry about what the numbers are. Fe got with S, Ca got with Cl. So double displacement reaction. Okay. Double D. Okay. This is single displacement. I didn't say that. Single displacement reaction because I have A, B, C. A pushes B out. This dude wants to dance with this girl. So he knocks this one out, go by itself. Okay. Single displacement reaction. A, B, C. You always look at these as like you have NO3, SO4, PO4, PO3, any of those. They're called polyatomic ions. You look at them as a single unit, and you always tell because it's NO3 here and NO3 over here. Okay? So that's a single displacement reaction. A very, 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 very common reaction. This actually produces pure silver, by the way. Okay, next screen. Carbon compound, reacting with oxygen, and only 2 products are carbon dioxide and water. Combustion reaction. Whoop. Okay. This is A, B put together through the reaction. I take them apart. Decomposition reaction. Okay. Here I have A. This is BC. A, and then BC. BC's here, A's here. This guy gets over here and pushes one out. Okay. So it's single displacement reaction. This is a very explosive reaction if you get this ignited, which I used to have my students do in my chemistry class at Westvigo. Would collect hydrogen and you blow it up. Okay. And then this last one here, this is A, this is B. I put them together. So it's called synthesis reaction. And that gets us all the way through the content. And that is this chapter, this unit. Okay? Have a good week.